In this video, we're going to be chatting a little bit about remote sensing and about Landsat and other USGS and NASA satellites. Now, you aren't going to be working on any assignments for this information. You won't be tested on this information, but this is a really critical piece to know about as you're entering into the broader world. And if this is something that excites you, this is something that we'll be doing a lot more of in advanced spatial analysis, which will be offered again next spring, hopefully. So we'll cover today, we'll talk a little bit about image classification. We'll talk about Landsat, the satellite, the USGS NASA satellites that have been up since the 70s, history of the program. Talk a little bit about land use change, how to access Landsat imagery. And then we'll have a series of videos on Google Earth Engine. We'll have a little tour of Google Earth Engine. We'll code assignment 4, the sea level rise exercise in Google Earth Engine in about 3 lines of code. And we'll do a little bit of a topic that Jess brought up, which is eutrophication in the Arabian Sea using MODIS, which is another satellite. So we'll dive into a brief little bit of coding around the Arabian Sea. And then I'm going to make available all the advanced GIS tutorials to you all, which delve deeper into Google Earth Engine and some of the custom interfaces that you can create and can code. So if any of you are interested with whether it's this semester or over the summer, check those out. They're all really interesting. We'll go into some basics right now before following up in a little bit more detail in the next video about the Landsat program in particular. So what is remote sensing? Remote sensing is the science of obtaining information about objects or areas from a distance, typically from aircraft or satellites. This information that's being collected from a distance is generally information that we can collect from sensors on satellites, cameras, on airplanes, drones, unmanned air vehicles, etc. And that information that we're collecting is generally information about how electromagnetic radiation or energy is reflecting off of various surfaces or being absorbed by various surfaces. Now, you'll remember this from earlier on when we were talking about NDVI and different bands of imagery when we're dealing with 4-band imagery. Visible light is this tiny little part of the electromagnetic spectrum. Near infrared, the type of light that we use to build NDVI, which you all are familiar with. Right here on the edge of the red, many satellites will detect light further up into the infrared, some a little bit further down this way, some way up into microwave and radio waves. Most sensors on satellites or airplanes are not collecting information continuously across this spectrum about how the surfaces are absorbing and reflecting at every given nanometer. Rather, they have sensors that can detect specific points across this range, which are then put into information called bands within images. The imagery we were dealing with for our midterm assignment was 4-band imagery. We had red, green, blue, and near infrared. Many satellites will produce 8, 9, 10, 11 bands of information. That's called multispectral data. Satellites that produce up into the hundreds of bands of information, that is really fine spectral resolution, are called hyperspectral satellites. This next piece is a little bit of a review, but as we remember, when we are creating images that we can see with our eye, we do that by combining red, green, and blue color bands. Even our digital cameras are doing this to create RGB composites that are visible with the human eye. Here's another sort of way of imagining and stacking that up together. So how do we turn that remotely sensed data into useful information? We can do this broadly in 2 different ways. We look at this picture of Rhode Island over here. This is just a picture, right? I couldn't tell you from this how many acres of farmland there are in Rhode Island or how many acres of developed land, let alone how that's changing over time if we were interested in understanding those dynamics. I couldn't tell you about eutrophication in the ocean or waterways without doing some kind of interpretation of the reflectance values calculated and captured by satellites or aircraft. So there are sort of two primary ways where we can collect information from these remotely sensed images. One is through supervised learning. The other is unsupervised learning. Now, unsupervised learning is a machine learning process that allows the computer to build relationships without any human input. That is, the computer will look at this image and it will say, okay, I see this big blue area. That's all very similar. I'm sure that's something. It's not going to know that it's water. It's not going to know that this clumpy area up here is all urban area around Providence. It's not going to know that these big chunks of green are forest. But a computer is going to look at the image and at all the bands in the image and say, this chunk here is similar. This chunk here is similar. I'm going to separate those into different classes. And then the user, you, comes in and can actually assign meaning to those classes to say, oh, that thing, that distinct thing that you pulled out, that's actually water. This over here, that's actually forest. This over here, that's urban land. Supervised learning switches that around a little bit, and it allows the user on the front to say, this is urban land, this is forested land, this is water, this is farmland. Hey, computer, given that you know those things, go look for other pixels on this image that look like farmland from the training data that I've created here, or look like water, or look like urban, and then allow the computer to build those relationships, sort of supervising that classification on the front end. Now I'm going to give you a little example here. I'm going to go over to Google Earth Engine, and we have some code back behind here that's running all of this. I'll probably go over this in one of the later videos, but I just wanted to point out that we have a bunch of code here that's running these algorithms that we're going to be looking at here. Here's the island of Nantucket off the southeast coast of Massachusetts. What we're looking at here is an image that was captured in July of 2019. It was a cloud-free, beautiful, sunny day down there in Nantucket. This is a Landsat image, 30-meter resolution pixels. What I'm going to do is I am going to ask the computer to run an unsupervised classification. That is, go ahead and all these places that you think might be similar, clump them into their own categories and spit out a response to me. Now, just looking at this from the beginning, one thing we might expect is maybe we expect this area here, which is sort of developed land, to get clumped together, right? We might expect this area here, this sort of grassy or foresty areas, to get clumped together as well. Water similarly might get clumped together. Let's take a look. I'm going to run this unsupervised classification and see what our outputs are. So that's kind of a little bit of a ugly, messy map here, but if we kind of turn it off and on a couple times, what we'll see is that the map is kind of picking up these sort of like yellow and blue areas are zones of developed land. That's kind of cool. It's picking out water bodies here in green really well. All these bays and things over here. That's pretty cool to see those turning off and on. But a lot of confusion around these grasslandy forested areas. Looks like there's a lot of variation in there and it's having a hard time picking them up. We would probably come back in and sort of smush those two classes together to get more of a uniform distribution. So this is unsupervised. This is just asking the computer to say which areas are similar to which other areas based on the reflectance values of all the different bands at each pixel. Next up, we'll do a supervised classification. On this image we're looking at, I want to come in and I want to say, okay, this is grassland. This is grassland. This is grassland. This one here, that's water. This is water. This is urban land right here. And this is also urban land. This is a runway. This is water. These look like farm fields over here. So do these. This is a beach. This is ocean. And by building this training data set, we can then ask the computer to go in and look for pixels that match these criteria, thus producing a classified image. And these tend to spit out things that look a little bit more like reality. In this example here, we've got yellow, or sort of this tan, reds and pinks and blacks are developed areas. So if we sort of turn that off, we can see those are sort of developed or bare ground areas. That holds up pretty well, right? We've got some developed areas here, developed areas here. That's pretty consistent. Greens are going to be either forested or open lands. These light blues are going to be wetlands, and these darker blues are going to be water bodies. So it looks like that supervised classification where we went in and we said, all right, in our next videos, we're going to be chatting a little bit more about Landsat satellites in particular, and about how we can access that data and what programs we might use to classify.